Here's another nice demonstration of induced charges. The setup I've got here is the Van de Graaff, which will get a strong positive charge, and I've got these two other spheres, which are currently touching each other. I'm going to run the Van de Graaff. We'll let it develop a nice big charge, and then we'll turn it off. And then we'll discharge the Van de Graaff, which is not touching the two spheres. Did that have an effect? Let's check this sphere on the left. Let's see if it has a charge. Does not appear to. I'm going to make one other adjustment in the routine. They're still touching each other. I'm going to repeat the experiment. But before I discharge the Van de Graaff, I'm going to separate the two. Let it run and charge up. Pull them apart. Off. Discharge. Now let's check the sphere on the left. As you can see, it's got a pretty strong charge. So what's going on? Well, when the two were touching each other, electrons could flow freely between them. And since the Van de Graaff dome was positively charged, electrons from both spheres flowed together into this one on the right. So there was a negative charge on the two spheres on the side closest to the Van de Graaff. Now, since they were connected, when I turned the Van de Graaff off and discharged it, all the electrons just went back where they ordinarily would. But the second time, when I pulled them apart, that couldn't happen. So the sphere on the right, which was closer to the dome, it ended up having to hold on to those extra electrons, gaining a negative charge. Where did the extra ones come from? They came from this guy, the sphere on the left. And because they were separate, now they couldn't come back. So this guy ended up with a net positive charge. So it's another nice example of induced charge.